Introducing ThermoCalc 2021A, which includes 16 new and updated databases, a property model for Bainite, a new and improved way for users to develop property models, and much more. The first time you start ThermoCalc 2021A, you may notice that the GUI has a new look and feel. The software has received an update that allows it to scale better on large and high-resolution screens, providing a better user experience for many of our users. ThermoCalc 2021A includes 9 new and 7 updated databases, as shown on the screen. The Thermodynamic and Properties database for magnesium-based alloys, TCMG6, adds several thermophysical properties, including electrical resistivity and thermal conductivity. The elements hydrogen and bismuth are added, and 11 new ternary and 12 new binary systems are assessed. The new database also includes several other improvements, which you can read about at the Release News section of our website. MobMG2, the companion mobility database, is updated to correspond to TCMG6. The Thermodynamic and Properties database for steel and Fe alloys, TCFE11, adds the thermophysical property surface tension. Additionally, molar volume is updated for this release. Hydrogen has been added to the relevant solution phases in this database. In previous versions, hydrogen was only included in the gas phase, but in this release, the complete systems are added. 37 new binary and 20 new ternary systems are assessed for this database, many of them for hydrogen. 12 binary and 7 ternary systems are also updated. The new database also includes several other improvements, which you can read about at the Release News section of our website. MobFE6, the companion mobility database, adds hydrogen and receives other updates to correspond to the new TCFE11. TCTI3, the Thermodynamic and Properties database for titanium and titanium aluminide-based alloys, adds the thermophysical properties viscosity and surface tension. Copper is also added in this release, a minor alloying element in titanium alloys. The database also adds 9 new binary and 13 new ternary systems. The corresponding mobility database, MobTI4, adds copper to 3 important phases and receives other updates to correspond to the new TCTI3. MobAL6, the mobility database for aluminum-based alloys, adds 3 elements in this release. Both of the third-party nuclear databases we offer, Mephisto 19 and Nuclea 19, have new versions for the 2021A release. The highlights are listed on the screen, and you can read the full details in the Release News section of our website. 7 databases have also been updated for the 2021A release, as shown on the screen. You can read about all of the new and updated databases on the Release News page on our website, or you can contact your local sales representative to discuss updating any of the new databases. ThermoCalc 2021A introduces a Bainite model for the Steel Model Library. The Bainite model describes the thermodynamics and isothermal kinetics of Bainite transformation from austenite. This model can calculate Bainite start temperature, transformation times, Bainite plate lengthening rate, and phase constitution at the final state. This release includes 1 new example to help users get started working with this new model. The Bainite model requires a license for the Steel Model Library, which is currently available for free to all users who have the databases TCFE9 or newer, and MobFE4 or newer, and a valid maintenance and support subscription. To inquire about getting a license for the Steel Model Library, contact your local sales representative. To learn more about the new Bainite model, read the release notes available on our website. ThermoCalc 2021A introduces a new way for users to develop property models using TCPython. Previously, users could develop property models using a Jython-based API called the Property Model Development Framework. But Jython is no longer being supported, so we are introducing a new framework. This new system allows for easier development of property models and significantly expands what can be done with user-developed models. For instance, because this new API uses the Python language, users can use any Python library, such as NumPy, SciPy, or scikit-learn within the property models, making model development quite powerful. This new system also allows the property models to perform any calculation type that is available in ThermoCalc. Previously, only single equilibrium calculations were supported. Property models created in TC/Python automatically show up in the Property Model Calculator in the graphical mode of ThermoCalc. Here they can be further configured, combined with other models, and run. Users who previously used the Property Model Development Framework to develop property models can still use their models in ThermoCalc, but they are encouraged to migrate them to TC/Python as soon as possible. This new feature requires a license for TC/Python. Contact your local ThermoCalc software representative if you are interested in learning more about this powerful new feature, or read about it in the TC/Python help under the Property Model Framework section. ThermoCalc 2021A includes 5 new property models, in addition to Bainite, 4 general models, and 1 steel-specific model. All of the new models include an example demonstrating how they work. The crack susceptibility coefficient model is used to calculate the hot tearing tendency during solidification. Hot tearing is one of the most common and serious defects encountered during the casting of aluminum and magnesium alloys, and this model can help users choose the right alloy composition to reduce the occurrence of this issue. Example PMG07 Hot crack susceptibility demonstrates how to set up the model. An accompanying video of the same name walks users step by step through setting up the calculation, offers an analysis of the results, and gives a basic description of the model. The T0 temperature model is a new property model that calculates the so-called T0 line. The T0 temperature is defined as the temperature where 2 phases of identical chemical compositions have the same molar Gibbs free energy. This temperature is an important quantity in the field of diffusionless phase transformations, such as Martensitic transformation, since it is the upper limit where diffusionless phase transformations can occur. Example PMG09 T0 temperature demonstrates this new model. The spinodal model is a new property model that calculates the spinodal line. The spinodal is defined by the condition where the second derivative of Gibbs free energy is 0. The locus of these points is known as the spinodal curve. One new example is included demonstrating this new model, PMG08 spinodal. The critical transformation temperature model is a new property model that is used to calculate critical transformation temperatures for steels. It can output the common transformation temperatures for steels including liquidus, solidus, A0, A1, and more, as shown on the screen. This new model is specific to steels and requires a license for the Steel Model Library. The new example, PMFE04, critical temperature, demonstrates this new model. The equilibrium with freeze-in temperature property model calculates equilibrium at the freeze-in temperature and evaluates the properties at a different temperature. The model can evaluate several properties such as electrical resistivity, electrical conductivity, thermal conductivity, and others, as shown on the screen. 2 examples are included in this release demonstrating the new model. Example PMG10, freeze in thermal conductivity, and example PMG11, freeze in electric conductivity. The Process Metallurgy module for steel and slag now allows users to change the pressure and reaction kinetics in the process schedule, valuable features for vacuum degassing processes. A new example, PMET07, vacuum oxygen decarburization kinetics, demonstrates these new features. A companion PDF is also available, which discusses the example in detail. The Process Metallurgy module includes several other updates, which you can read about in the Release News section of our website. Users can now pause diffusion module DICTRA simulations in the graphical mode to change left and right boundary conditions, then continue with the calculation. This is useful, for example, when you want to simulate carburization, because it is common to first have a step with high carbon activity in the furnace for the actual carburization, and then lower it and allow the carbon in the specimen to diffuse without further increased carbon content. For users who develop their own databases, a new database editing tool is introduced in ThermoCalc 2021A, the TDB editor. This tool speeds up the database editing process by providing immediate feedback through syntax coloring, syntax checking, and by allowing formatting and easy navigation to items of interest in the TDB file. This new editor is available for free as part of the ThermoCalc 2021A release, but it does require additional open-source programs to run. The editor is currently only supported on Windows and Linux platforms, not on Mac. To learn more about the TDB editor, read the release notes available on our website. To learn more about the items discussed in this video and all the other new features, bug fixes, and updates in the ThermoCalc 2021A release, read the complete release notes available on our website at thermocalc.com/release news.